Hello, welcome to the lecture, and I'm Thomas Ming-Shui Chang. I've been working in artificial cell for more than 60 years. It's a pleasure to briefly summarize this area for you. First, let's ask a question. Let's go to the next topic, blood substitute based on nanotechnology and nanobiotherapeutic. This is a rather complicated subject. I will just go briefly. As we mentioned before, we can make artificial red blood cell that's exactly the same content of red blood cell except with artificial membrane. We can make it down to 1 micron. Red blood cell is 7 micron, but even then it's still too big to circulate for enough length of time. This led to the start of nanobiotechnology to make this very small. There are different basic methods of preparing artificial cell. One of this is by emulsion method to form artificial cell with the membrane. Another approach is nanobiotechnology based on the cross-linking of hemoglobin into polyhemoglobin. Another way is by conjugation, whereby hemoglobin is attached to polymer in the form of polyamine or dextran, or most importantly is polyethylene glycol, PEG. This is done as follows. Hemoglobin and enzymes in free solution are example cross-linked into polyhemoglobin, soluble polyhemoglobin, and the cross-linking agent could be diacid or glutaraldehyde. Glutaraldehyde is the one that's most commonly used. There was no initial interest in these because people perhaps it's a bit too advanced, too early. So it's until 1989 when HIV contaminated blood come. There's nothing to help the patient, and many patients got infected with HIV from donor blood. At that time only that people around the world, as shown here, actively start to investigate different type polyhemoglobin, conjugate hemoglobin, crossing textrameric hemoglobin, also recombinant and bioengineered hemoglobin, and also encapsulated hemoglobin. Let's take one example that's most extensively developed. This is polyhemoglobin crossing with glutaraldehyde. BioPure used mobile hemoglobin to cross-link with glutaraldehyde, resulting in glutamate 250. They did clinical trial in patients on orthopedic surgery, and it was approved in 2002 in South Africa and Russia to avoid the use of HIV contaminated donor blood. So, original aim reached to avoid use of HIV donor blood. What about its use in other conditions? Arterial obstruction, for instance, heart attack, stroke, can quite often be caused by obstruction due to atherosclerotic plaque. In this situation, red blood cell particle cannot go through, result in ischemia. Can we use hemoglobin, polyhemoglobin solution? Because it's a solution, so it should be able to pass through. Yes, it does pass through, and it does supply oxygen. The only trouble is that it causes oxygen radical release and ischemia reperfusion injury, resulting in polyhemoglobin superoxide dismutase and catalase. And we look at the effect on brain edema in a case of hemorrhagic shock and ischemic cerebral ischemia. The results shown here: control, polyhemoglobin, polymer with the enzyme, showing that it doesn't cause edema. However, you have to cross-link the enzyme. If you don't cross-link it, the enzyme will remove very quickly. Because of this basic research, a lot of other people start to look at different ways to remove oxygen radical. Another one is in severe blood loss in emergency, accident, natural or man-made disaster. For instance, donor blood in emergency. It has blood group. And because of the blood group, you have to cross-match it before you can give it to the patient. For instance, you have to wait for the ambulance, bring it to the hospital to cross-match before you can give it to the patient, resulting in much delay. Now, polyhemoglobin has no blood group, so you can give it right away in the ambulance without delay of going back to the hospital. Can you do this? Well, polyhemoglobin polyhem from Northfield has been clinically tried in 714 patients. What they do is they give this right in the ambulance, polyhem, with control group giving saline. What they found is that when they reach the hospital, no need for blood transfusion. In the case of polyhem, in saline control, they need blood half an hour quickly. However, there is 3% non-fatal cardiac side effect compared to 0.6% in the control group. However, looking at risk-benefit, if there is no blood available, you only have saline, then lots of patients will have died. But and then you can give polyhemoglobin, saving lots of life. But if you have blood available, you may want to solve the problem of cardiac side effect for more widespread use. Trosted et al. Found that myocardial ischemia is related to the increase in tissue oxygen, tissue PCO2 related to myocardial ischemia. This being the case, we look into a way to solve the problem. For instance, red blood cells contain hemoglobin and enzyme. One of these is carbonate anhydrase that is responsible for removing CO2. So what we did was to cross-link this together into a nanotherapeutic red blood cell containing hemoglobin cross-linked to 3 enzymes. What is good is that you can increase the enzyme to 6 times that of red blood cell. You can also therefore increase the function up to 6 times. This shows the ability to increase the enzyme concentration up to 6 times that of red blood cell for all 3 enzymes. So let's look at what happened in animal study. This is animal study with rats remove 2/3 of total blood volume and in shock for 90 minutes. We follow the tissue PCO2 and it keeps increasing with time. We then infuse different type of solution. As you can see here, the one with the polyhemoglobin and the 3 enzyme is better than blood, is even better than polyhemoglobin. So since increase in PCO2 is related to increase in heart ischemia, since this is much more efficient in removing PCO2. So let's see what happens. If you look at the recovery of the heart from hemorrhagic shock and ischemia, let's look at using the recovery of ST elevation of ECG. Control saline, no recovery. Polyhemoglobin, 60% recovery. Blood, 40% recovery. This new nanobiotherapeutic recovered to 30% of normal. Thus, recovery better than parahemoglobin, even better than blood. If you look at histology of the heart, the blood caused some damage, polyhemoglobin caused more damage, and the new nanobiotherapeutic has no tissue injury signal. For long-term safety study and empirical study, we inject the blood substitutes once a week, 5% volume, total blood volume, into animal, and then analyze biochemistry, immunology after each week. After 4 weeks, on week 5, we exchange the 50% blood volume with this blood substitute and look at the effect on anaphylactic shock. And week 6, we look at biochemistry, growth, and immunology. The result is rather complicated, but it's shown here. You'll refer to the publication. In summary, there's no significant difference from control in body weight, biochemistry, blood pressure, in antibody immunology, and in the no anaphylactic reaction using tryptase analysis. As a result, the long-term safety is demonstrated and there's no immunological problem. The temperature stability is also important at the fridge, 4 degrees, and room temperature. Donor blood, 42 days, the fridge, 1 day, room temperature. Polyhemoglobin, SOD with the enzyme, the 3 enzymes in solution, 320 days in fridge, 51 days in room temperature. But if you lyophilize it, you have more than 320 days, and you can be 220 days in room temperature. You can easily redissolve it before use. Heat sterilization, 70 degrees for 2 hours. The liquid form cannot stand it, but the lyophilized form can withstand it. Cost of the enzyme is also important. For 500 cc of the nanobiotherapeutic, it costs impossibly $250,000 using commercial pure enzyme. But if you use our enzyme extraction method to extract the enzyme from red blood cell, it only costs a fraction of this. So we have the soluble nanohemoglobin with functional membrane. You can also prepare particularly nano-red blood cell with non-functional membrane, PEG, PLL, or PEG lipid membrane. For more detail, you'll refer to the book on nanobiotherapeutic-based blood substitute. Finally, may I invite you to visit the website. We don't have time to go into any detail. This is just a very brief summary. If you are interested, the detail in articles, videos, and books are available. If you have any questions, I'll be happy to answer, and this is my email address.